right, good morning. This is John Driscoll with Boston Engineering. Appreciate you guys taking a few minutes to half hour with us. Know your time is very valuable. Hopefully everyone's safe and out there. And let's be respectful of the people that have joined. So I want to keep this to a hard stop at noon, so it's 11:30. So I think we'll kick it off. So again, today's session will be showcasing Discovery Live, powered by Ansys. And this is John Driscoll, General Manager with Boston Engineering. Also have Dan Shaw, who leads our Ansys Solution Sales. And Jim Shaw will be our subject matter expert today as well, and doing a lot of the presentation as well as answering some question and answers, hopefully throughout the webinar as well as at the end as well. So thank you for joining us. It's important to note, just from a Boston Engineering perspective, that we do have some strategic partnerships. We were approached by Ansys as well as PTC as longtime customers to support their products, help companies be successful with their solutions and technology. As a consulting organization, it's important that we partner with market-leading companies, but as you can imagine, we interface and need to exchange data and work in many different tools and platforms. We've partnered with PTC and ANSYS, but we do have some strategic partnerships and use other different CAD tools. And the nice thing with today's technology with ANSYS and PTC, we're both taking a very open approach to working with multi-CAD environments and things of that sort. So really focusing on simulation and the critical role it plays in the product development process. Just to take a few seconds, just to make sure folks aren't aware, we've done a few series of webcasts. This is the fourth, or potentially third, I apologize. But PTC as a solutions partner, they've strategically selected and will be using Ansys solutions and solvers and simulation capabilities underneath the hood within the Creo platform. So given that we're strategic partners with both organizations, we wanted to provide our customers with best-in-class technology and capabilities to ultimately provide better products and higher quality products. So with that being said, appreciate you joining us. I'll transition over to Jim Shaw, and I think you guys will be excited about what he covers today.
Awesome, thanks, John. Can you hear me okay?
Yeah, you're great.
Fantastic. So yeah, like John said, I want to keep it short here, but what I wanted to show you guys is some of the capabilities within Ansys Discovery Live on fluid analysis. And there's two sort of main, let's say, use cases that we really think about. And I'd say this probably covers, let's say 90% of the industrial applications is internal flow and external flow. And so we're going to do a quick demo on internal flow. We have a mixing pipe. We're going to look at water, and then we're going to slide over to another model, and we're going to look at external flow. We'll look at wind loading on a billboard. And so a couple of things that we wanted to kind of highlight through the next few minutes here is exactly what the advantages are of Ansys Discovery Live, particularly for fluids. So if we want to make quick changes up front conceptually, look at design trends before we start digging into the dirty details, then Ansys Discovery Live fluid analysis is really going to help out. And again, this should be part of, hopefully everyone here has a sort of a larger package of computer-aided engineering software, right? So we want to be using a lot of the simulation tools, whether it's fluids or structures or electromagnetics, to really kind of offset some of the, I'll say, old school R&D prototype and testing. So we're going to cover those two cases and then any Q&A afterwards. I'm a long-winded person, so I'm going to try my best, John, to stick to the time allotted here. So let's move over to a quick intro. So for those who aren't familiar or those who are new to the Ansys sort of portfolio, there's really sort of three categories of tools. Across the top, the actual brand name of the software, we've got Discovery Live, which is what we're going to be talking about today. We've got Discovery AIM, and we've got the sort of the flagship, if you will, CFD tools. Probably heard of them. They've been around for many, many, many decades, Fluent and CFX. And so these are the three sort of categories, if you will, of tools that Ansys offers. And currently in the year 2020, we do still have to make a trade-off between speed and accuracy. And that's just the way it is with computational fluid dynamics and mechanics and a lot of the computer-aided engineering software that we have. And so what Ansys has done by developing Discovery Live is put in a solution for those designers or engineers or analysts or teams or manufacturers who are looking for an analysis tool that caters more to the speed than it does to the accuracy. And there's a tool for every purpose, right? Sometimes you need a blunt hammer, and sometimes you need a very, very precise, hammer. And so Discovery Lab's a little more of the speedy, blunt hammer, if you will. One of the things that makes it really, really fast, and we'll see it today firsthand, is the fact that all of the physics is solving on the GPU. So that's the graphical processor, right? So one of the challenges with Fluids, very, very sort of rich, if you will, in regards to post-processing. There's a variety of different ways to visualize it, whether it's animations or colors. And so we're constantly trying to move big pieces of data back and forth from the CPU to the hardware, back to the graphics card, and that can take a lot of time. And so Discovery Live, by keeping everything on the graphics card, by solving there, by showing you results from there, we actually speed up that process quite a bit. We do take a hit of accuracy, of course. We'll talk about that in a little bit, but I think you guys will be very impressed. There's always a drive to be a little bit faster. So we'll see how fast this can really be. Okay, I'm going to jump in. We're going to start off with an internal flow. So I'm just going to slide over to Discovery Live. And so this is a step file. It is an assembly that I've pulled in. And so for those who are relatively new to the graphical interface, I'll do a quick sort of tour. Across the top, we've got all kinds of capability. What's really interesting is that inside of Ansys Discovery Live is a full CAD modeler. So we don't have to come out of the tool to go back into whether it's Creo or SolidWorks or Fusion or Onshape, wherever you're doing your CAD modeling. In this particular case, this is a step file, but I could, if I wanted to, create the geometry from within Ansys Discovery Live. For those who are familiar with Ansys, this is actually SpaceClaim, a lot of the functionality from the SpaceClaim modeler, including some of the direct editing, which we'll play with in a second. We've, of course, got a variety of display tools. We can actually create and build assemblies in here. So we've got the ability to import parts and assemble them and mate them together. We've got a variety of measuring tools, as all CAD does. We can do some interference checks if we need to, mass properties. Facets. What's really cool is you can actually manipulate like an STL file or anything that's sort of triangulated. So let's say, for example, you've got a project car at home. I'm a bit of a car guy. And so let's say you say, hey, I want to know if I need to put a wing on it. I want to make this more aerodynamic. You can scan it and then take that resulting point cloud, get a tessellated body out of it, and then import it directly into here. Between the Facets tab and the Repair tab, you've got pretty much every single tool needed to sort of prepare that model for fluid analysis. For those who are familiar with fluid analysis, it can be a little testy sometimes, right? If we need to stitch up gaps or make sure there's no interferences, and sometimes that can be a very, very laborious process. So a lot of tools really embedded into the analysis here. A few more, prepare, creating enclosures, we'll do that in a second. And then Workbench. So, if you've got a full suite of analysis software, if you happen to already be an Ansys customer, maybe you're using some of the Ansys Discovery Live for some upfront type analysis, more qualitative, more design trends. And then when it's time to get into the more heavy duty stuff, you can actually take this model and port it right into Fluent directly and basically pick up where you left off. So it really is sort of an upfront tool, and hopefully is part of a wide variety of tools. On the left-hand side, we've got a little bit of shortcuts here. We're going to play with some of the edit tools in a second. And on the right-hand side, we've got our model tree. So if we need to turn on and off some of the volumes, you can see inside of this pipe, we've got a little bit of a turning vane, if you will. And we're going to analyze this pipe in a second. We're going to start manipulating that geometry, and we'll see how fast we can do it. So let me just get this split pipe show back up again. Oops. Okay. So towards the bottom, we're going to build our analysis. So first, I'm going to choose on Create Solution. And so we're going to see here, we'll expose the different physics we have available to us within Ansys Discovery Live. I'm going to click on the fluid behavior. And then it's going to say I have an object made of air. Well, I don't. It's actually steel. But what I want to do is I want to fill it full of water. So I'm going to be analyzing water, and I'm going to automatically create a fluid volume. And I'm going to do that for internal flow. Again, this is a pipe. I'm going to be trying to analyze the water going through it. In fluid dynamics, because we're analyzing the actual fluid itself, we have to have some sort of volume to represent that fluid that we can ultimately then solve on. So I'm just going to hit create here. And now in the upper left-hand corner, you can see it's prompting me select the inlet face. And so I'm going to select the inlet faces. I've got on the right-hand side, I've got my inlet, and on the left-hand side, I'm going to have my outlet. And so all I'm going to do here is basically tell ANSYS Discovery Live exactly where to put those. And if I just kind of hover over this face right here, you can see it gives that green arrow at the center, and I'll say that is one of my inlets. And I'm just going to hover over this one at the bottom, and I'm just going to hit Control, toggle that I want that to be an inlet. And I'm going to come over to my outlet, and I'm just going to click on that. And right now I'm getting fluid results. Literally within a few seconds, I have capped my geometry. I have created a fluid volume within the internal pipes, and I have begun solving. So let's look at exactly what happened. On the left-hand side, I've actually created all of my physics. So I have applied water to that volume. First off, if we look up here, I've actually created that volume. So that happened on the fly. Then I have assigned that a water property, and I've given my inlet boundary conditions here of flow, for example, 0.5. If I wanted to change that to 1, it instantly changes, and I want to change that to 1, and it instantly changes. And so we don't have to stop the analysis. We don't have to pause anything. We don't have to remesh. It's instantly updating those results. And then a typical outlet boundary condition for internal flow is just an outlet pressure of 0 pH here. And so immediately I've hidden some of the structure so I can see some of the fluids. We've got some post-processing options down at the bottom, and on the right we've got our color legend. And you can see right now there's actually a bit of a timer going. So what's happening right now is we're actually constantly analyzing a transient flow analysis. So this is actually solving right now and continuing to solve. And that's one of the ways that as I make changes, whether it's to my boundary conditions or if I change my material properties, or as we'll see in a second, as I change my geometry, since it's constantly running a transient analysis, it's going to immediately update. Some of the things that we're looking at here in the legend. So this is a max value. What that is actually a bit of I'm kind of seeing through the fluid a little bit. If you notice, no matter how I rotate it, I can always get a good idea of sort of where that max velocity is inside the pipe. And so this is a great tool. I don't have to fumble around with any of the slicing through the planes and trying to find it. I'm actually kind of looking through the fluid. Another cool one is sort of the composite, which again is a little bit of a composite value of all of the different sort of velocities. And again, it's more qualitative than quantitative. What that means is I'm just getting a visual, idea. Where is it fast? Where is it slow? And we're going to change this back to, we'll change this over to max. We've got ISO surfaces, which is another sort of way to post-process. We basically show a surface of constant velocity. I'm going to go back to the max value for a second. Actually, I'm going to go back to, go to surface, and I'm going to turn on my cut plane. And so automatically, again, it's a 3D analysis, but I just create a sort of a 2D plane that goes right through the center. I'm just going to snap this view, and we're going to get a good idea of what's happening inside here. And so we can see that I've got an inlet here. I've got a little bit of a wake zone. This is slow velocity. It's coming down and coming out to the left-hand side. If I wanted to look at some streamlines, I can turn those on. And one of the things that's really, really neat is how interactive the post-processing is. And this is really because I'm on the GPU. So again, I've got my graphics card doing all the work right now. It's constantly solving a transient analysis, and it's constantly updating exactly what I'm asking it to do. I can live manipulate this. So for example, if I take this, I just want to move it, double click to rotate, slide it down, move it over a little bit. I can just drag that around, and I can manipulate that very, very interactively. I don't know really of any other tools that allow that level of interaction and that speed of updating without having to pause something or resolve or remesh or something. So there's some streamlines. Here are our particle traces or our particles. So it starts off by giving us sort of the full view, if you will. Again, just a visualization of where is it slow and where is it fast. I can turn on an emitter here and just put it at the top, and I can make that just a little bit bigger. And I can, right now, it's actually solving the analysis as well as sort of post-processing on the fly what these particles are doing. If I pause the analysis for a second, okay, now I'm using that GPU for just post-processing. I get a little bit faster rendering, and I can kind of manipulate this. It is a transient analysis, but when I pause it, I kind of freeze time for a second, and I can kind of manipulate and see what happens here. So We can change the size, we can change transparency, very interactive. Half the challenge of a CFD analyst or a designer is communicating some of the results. And so this is just a whole slew of tools that we can use to do that. Additionally, we've got some vectors, and then we've got a really cool one called the direction field, which is, let me turn off the vectors. The direction field is kind of a mix of velocity vectors and values and stuff. So it's kind of a neat one. That one's relatively new. We're going to go back to plane for a second, and I'm going to make a geometry edit because a lot of the functionality we've seen right now, very interactive, very quick. That's great, but not necessarily the most innovative thing in the world for those of us who've been doing a lot of fluid analysis. Those are relatively standard, but what I'm about to do is not. And what that is directly modify my geometry. So let's say I'm going to go in here. I'm just going to hide some of these structural parts for a second. I'm just going to look at my fluid volume. So right now, I'm just looking at that fluid volume. I'm going to zoom in here. And let's say, for example, I wanted to remove some of the wake zone here. I just want to play around with this vein. So I'm just going to zoom in. I'm going to hit the pull feature, and I'm just scrolling on my mouse. So I can scroll right through the model, and I've highlighted that top surface, and I'm literally just going to drag it right now, and it automatically updates. And so I didn't have to remesh. I didn't have to go back into a CAD tool. I didn't have to troubleshoot anything. It was literally as soon as I clicked off of the pull arrow, it automatically started updating. You can see I've got some of the transient sort of wake effects happening down here. Escape out of that. You can kind of see down here. Let's say I wanted to slide this over a little bit so I could hit the move tool. I'm going to go right to this face right here, and I'm going to scroll, control select that. I'll zoom out, and I'm just going to take this top part, and you can see it automatically updates that vein. As soon as I let go, boom, resets the analysis, starts solving the transient flow analysis again. So I'm interactively modifying my geometry and seeing instantly what the update is to the flow. Last one here, if I wanted to, again, grab, I'll do the move again. I'm going to grab these guys. I'm going to zoom out so we can see what happens. And I'm just going to rotate that. So I can actually just rotate that geometry. As soon as I let go, instantly, I start getting new results again. So it happens that fast. It's really hard to believe. Again, it's all because it's happening on the GPU. The GPU just takes that geometry, converts it into a bunch of flow equations, and just starts giving us results and keeps solving. So that's how fast it can really work using all the CAD embedded tools. Very cool stuff. That's an example of internal flow. And then the other sort of typical example that we do, I'm going to save this. Let's hit save this. The other example that we do in fluid dynamics that represents a lot of is the external aerodynamic application. So I'm just going to hit open here, and you can see I've got my step file. There are literally any single CAD tool that you use. So if you are in SpaceFam already, right? So CATIA, I'm in Creo, I'm in ECAD. If you want to import some of your electronic CAD files, I can get my IGES. Some old school ISIM CFD, generic Parasol, I'm in SolidWorks, Solid Edge, you name it. So this can automatically import any of those. You don't need a third-party translator. You don't need someone to send you the step. I just happen to have a step. So let's grab that step file, hit open, and I am going to be presented with my geometry. So this is a little bit of a different model. So it's hard to tell on the computer, but it is full size. It does have a little bit of detail in here. You can see some of the ribs in here. There's some of the holes. We'll see if that gets picked up by the fluid analysis or not. But again, this is an upfront tool. I'm looking at big picture trends. I'm not really analyzing the very specific things that might be happening right at some of those small features. Okay. Down at the bottom, I'm going to create a new fluid simulation. So I'll hit create solution. I'm going to click on my fluid. This time I'm going to leave it at the default for air, and I'm going to create a fluid volume for external flow. So we'll hit create here, and I'm automatically prompted with my binding box, right? In the upper left-hand corner, I'm going to say, asking me, where's my inlet? So I'm going to come right here. And then the next question, and the only other question we have is, where's the ground, right? And I'm going to grab that ground right there, and within 3 seconds, 5 seconds, I'm going to crank up my little speed fidelity slider here. So this is really where we're trading off in how much of that RAM, so how much of that graphical RAM we want to use. So in some cases, we want to crank that up, and we're going to see some of the results here. So I'm just going to, yeah, within 5 seconds, we're getting external aerodynamic flow. This automatically built a box around my geometry, assigned air to it, gave me a flow velocity of 10 meters per second, which I can change if I wanted to. And then I have an outlet pressure. Again, this is a typical boundary condition. And then it automatically gave me these slip symmetry planes. So we don't want to calculate those as walls. We want to have them slip. And so that's all done automatically when I bring in my geometry and I say I'm doing external aerodynamics. We've got all the same tools back here, which are really cool. But what I want to do for this one real quick is show you one of the quantitative tools. So we actually have a calculator, which is like a probe, if you will, or some sort of extraction of value. And so I'm going to pull out this force in the Z direction. The Z direction, if you can see in the bottom left-hand corner, that is our flow direction, and it's going to be in the negative because we're going from left to right. So I'm going to hit force in the Z direction. I'm just going to grab this face right here. Oops, hit select. I'm going to grab that face right there, hit the checkbox, and I get a nice sort of interactive chart. That is not. Try that one more time. Z direction, face, chart. We're not getting an update there, so I'm not sure what's happening. But what we can do is extract out forces and pressures. The force here, which I'm not quite, NPA times millimeters squared, is kind of a weird one. If we wanted to change the units on the fly, I can just go to live options, change my units to imperial, hit OK. I'm going to get my PSI times inches squared. So I'm getting pressure, I multiply by that area, and I get my pounds. And so what I could do if I wanted, for example, just going to minimize that. If I wanted, I could zoom in and I say, I want to make a design change. And let's say I just want to add a quick round, something to make it a little bit nicer to go around. So let's say I'm going to pull, and this is a really, really cool option for adding a round to a sharp corner. I'm going to grab that corner, grab this corner, and I'm going to grab that corner. And when I'm in the pull tool, I just get my arrow, and all I'm going to do is start dragging my mouse, and I immediately start adding a round to that. And so if I just add that round as soon as I let go of the tool, again, I'm going to start analyzing immediately. And so that's the quick geometry update. That's the quick analysis that we can do within Ansys Discovery Live for fluid dynamics. So if you're not in the fluid dynamics tool, this is a fantastic tool for giving you that, what if scenario very early on. If you are using CFD already, this would be a great combination of, I'm spending a lot of time in meshing and CAD geometry and preparing, and then I'm waiting for post-processing. Maybe I'm using the cloud, so I'm moving, gigs and gigs and gigs of data back and forth. It's just taking a long time. So if you're taking a long time and you're not doing valuable work, then you might want to take a peek at using some of the Ansys Discovery Live Fluids functionality. Just looking at the time here, I do want to have a little bit at the end for a Q&A, but there's a couple slides I want to talk about. The first is, this is a question that we've gotten quite a bit here as we've been doing a lot of Discovery Live and Discovery AIM and Ansys support and deployment, but when would I want to use Discovery Live versus using some of the more traditional tools? Another way to ask that question, when would I want to use a GPU solver, fast, quick, interactive, speed over accuracy, versus when do I really want to dig in and invest my time in the deployment and the training and the hardware, if you will, needed for all of the Discovery AIM and Fluent CFX tools. So I would say in general, and this is just high level, Discovery Live, if you want to visualize turbulence, right? So turbulence is time dependent, it's length dependent, it's about dynamic in every possible variable. And so to visualize turbulence in a traditional CFD tool, you're talking about a transient analysis, you're talking about a lot of refinement for the mesh and a lot of time invested. So if you really just want to show your boss or a customer or a client, hey, this is what the turbulence looks like, just plop in Discovery Live and get a nice animation or video. Immediate design impacts, right? Upfront concepts and features. I want to look at certain trends in, what about this, what about that, and what's the impact of the fluid flow. Easy to do, fast to do in Discovery Live, not as much time invested so much as compared to Fluent, for example. The undo button. I can go back and hit Control Z infinitely back in Discovery Live and go back to the beginning. So if you make any of those geometry edits and you want to undo that, boom, you can. And so that's not necessarily easy to do if you're using a more traditional sort of CAD mesh solve process. Some of the things that you might want to, if you've got a problem that's a long pipe and you're looking to calculate pressure drop, or if you're doing high-speed compressible flow, really anything when you're really looking at what we call near wall refinement or boundary layer. If you really want to understand what's happening at that wall, zoom in really close. What happens if I have different textures and different surface finishes on that? Then you're going to want to have the detail. You're going to want to use a traditional mesher and really dig in. And any of the complex physics, of course, you'd want to use Fluent or CFX. High aspect ratio geometry, so very large models with a lot of detail, and you want to resolve that detail, then you'll want to use a more traditional sort of mesher, if you will. But a lot of times, what's going on with the flow isn't due to the small details, it's really due to the bigger picture. And Discovery Live captures that really well. If you want to get a deeper understanding of when to use stuff, if you've got a problem that's not listed here, just shoot us a quick email, and we'll be able to tell you, what works, what doesn't. We're constantly playing with the tools. We're constantly pushing the limits, as you can see, trying to grab some stuff out of the analysis every once in a while, and we're always trying to find out what works and what doesn't. And with that, this is really the end of, we've done 3 now demos, or excuse me, webinars. And so we've shown fluids and structures of heat transfer now. Terry last month and the month before did some great stuff showing the version of Ansys Discovery Live that's in Creo. But the bottom line is you really have to try it hands-on to believe it, really, to believe the speed and to try your geometry, right? Anytime we have a new simulation tool, it's like, I want to try my own geometry. So shoot us a quick email. We'll get you a quick demo. We can probably get you a key by the end of the day, 30 days, and try it out. And there's a whole online forum. There's a whole, hundreds of thousands of people who are using this that you can link into and say, hey, what about this? What about that? And get some ideas. So really cool stuff. We've been playing with it, and we can't stop. Okay. That being said, I do want to leave some time for Q&A, but before we wrap up, this is the middle of a whole series of simulation events. I mentioned Terry did a couple on back in March and early this month on the Creo Simulate Live, which is the sort of Creo embedded version of this. Coming up in June, we are sponsoring one of the sponsors for Simulation World, which is Ansys's whole online webinar, live interactive multi-physics. So if you want to see simulation and hear from people who are doing it and see all kinds of applications and see us, we'll be there. So that's great. That's coming up. And then July and further on in this year, we're going to be creating a lot more webinars. Don's going to be doing a great one on Creo mold analysis, and then I'm going to be back at the helm, so to speak, doing some more of the other side of the chart, some more accurate tools, if you will, Discovery AIM, Mechanical Fluent, CFX, and some of the EMAG tools as well. So that being said, I'm going to go back to I'll just go back to this slide right here and focus on Ansys Discovery Live. And with that, are there any questions that we have? Go ahead and unmute yourself, and I'll keep an eye on the chat here. Now's the time to ask the questions. Anything related to simulations?
Yeah, Jim, I would just say, this is John Driscoll. If there's not anything out there, I mean, just kind of think of it as, it's technology, can help in the product development process, but really looking at, what's the value, what's the payback, if you change your process or look to implement this type of technology around, lowering your life cycle costs, potentially, obviously, ultimately always looking about reducing time to market. Can you get your product to market faster? Can you increase the quality and performance? Those kind of go hand in hand or are critically important. And can you find opportunities to reduce the product development costs? So, always tying the technology back to the business, back to the problem, and, the products that you're designing, and ultimately allowing this technology to streamline a lot of those processes. So I just want to make sure you kind of correlate the technology and the power and the capabilities back to, what are the benefits to you as a designer out there? What are the benefits to the business, especially if you're looking to potentially communicate to a manager or, an executive that, technology can improve the way you design and get your products to manufacturing, etc.
Awesome. Well, so Sam's got a question there. Is a limit on wind flow speed? Yeah, so the focus here would be on, I would say, incompressible flow. So depending on the application, you could be looking at, a maximum Mach number of 0.3, maybe 0.5 or 0.7. But right now, it's really going to be looking at, some of your low-speed airflow or water flow, incompressible. Tristan's got a great question. Will this tool be available for Ansys Cloud? That's a great question for Ansys. I'm going to go out on a limb here. I might get in trouble, but the value of a GPU-based solver like this is, I have a laptop with 4 gigs of video RAM. That's the absolute minimum needed to run the tool. Laptops nowadays are coming out with 6, 8, 12. And NVIDIA, of course, is just driving that whole market of GPU power. And so it may, I don't know. It's going to be a matter of, is the Ansys Cloud going to provide any value that we can't already get locally, right? Because anytime we have to talk about bringing something, or sending something remotely, there's going to be an additional sort of overhead. Who knows? It could be a few seconds, but right now, some of the larger models, we do have some bandwidth issues on large stuff for the CPU-based stuff, which is one of the reasons why Ansys Discovery Live was developed straight up with the GPU, so that we can keep it local, keep it fast. Great question.
Perfect. Well, again, appreciate everybody for joining us. It's noon on the button here, so Jim, great job on pushing through, and obviously for everyone that's joined. We'll make these recordings available. Obviously, as Jim noted, we got a number of future events upcoming, and please reach out to us with any questions. Part of the ecosystem, and would love to make sure you guys are successful with simulation at the end of the day. However it may be implemented in your product development process. So enjoy the rest of your day, be safe, and thank you for your time.
Thanks, everybody.